All right. It is Advent of Code, day 10. Okay, this is a grid. It is a grid. Vertical pipe, bend. Interesting. Okay. Animal enters. Come to the pipe that contains animals. One large. Okay, so we know it's one large continuous loop. There's an animal somewhere in the pipe. Wait, I'm confused. S is the starting position. There's a pipe, but we don't know what shape it has. Oh, okay, so we got to figure it out. Oh, that's fine. Well, we know that everything else is connected, so... many pipes that aren't connected to the loop. That's unfortunate. What's the actual question? How many steps along the loop does it take to get the starting position to the point farthest from the starting position? Farthest in what sense? L1? Or farthest in pipe space? Okay, well, since we have this, I think we can just connect everything. So what we'll do... let's do this. And if it goes off the edge, I think we just ignore it, right? Okay, well anyways, let's do XY, and then okay, so basically the question is we need we want to find the connections. So if then x is the first coordinate, so it's x minus 1 y and x plus 1 y. So it'd be a great time for Python's switch statement that I unfortunately am not using. I think it's in 3.10 though, which I don't think I have right now. Okay, now I need to think. 90 degree connecting north and east. So north is x minus 1y, east is xy plus 1. J is north and west. It's north. And, oh, whoops, sorry, I just copied that. West is y minus 1. Let me double check that. Yeah, y is actually the horizontal coordinate here because it's the second index into the list. 7 is south and west. South is plus 1. West, we just said, is y minus 1. South and east. East is y plus 1. Yep. Okay. And then as the starting position, we don't know what it is. And what we'll do is, okay, I think we're just gonna run a connected components. And then, yeah, so gr of xy is equal to adjacencies. We'll make it, it's not necessary, but, okay, and then, okay, so if x is in range n and y in range m, then we continue. If we do this, then colors of x and y is equal to c for nx and y in graph of of, or sorry, if xy not, I guess it also needs to have a pipe on it, so it needs to be and xy and gr. So what we'll do is gr xy and x and y, c, if and x and y not cc. Cool. And then what we do is for x in range n, next color, and then dfs x, y, and c. I think we can just do this. And then what I want to know is, so if it's equal to s, do that. Oopsies. Okay, that's not great. We are marking it. So we do this DFS, and then we set this, and we only recurse if it's not in there. So I think we just need a sys.set recursion limit. Set it really big. Still running. If we started the shell. Okay, I definitely have an infinite recursion bug here, right? What's the size of this? Wow, okay. It's only 140 by 140, so I'm clearly doing something wrong. Oh, this is definitely going to be a silly bug. I know it. You're kidding, right? Is that too much to fit? Ugh. I always get burned by this. Do this. And then we add adjacencies. Okay. And finally, eventually we'll just be done, right? What is going on? Oh, whoops. Okay. Well, this one genuinely is. Right? Can I really not write a connected component search? I mean, it shouldn't get bigger than like 140 squared. Is it not? Is it really never going down? Well, 196? Clearly there's a problem in here, right? Oh yeah, the problem happened like way before this. Okay. Oh, what am I doing? This is crazy. I'm not overwriting N and M, am I? No. If it's in there, then these should just be 2 or 0. I don't know why they're 0 sometimes. Oh, that's why. Oh, okay. I don't think this is a problem. Maybe it was. Nope. On ship. Okay, so if we add it to the queue, Oh. Oh my god. That is ridiculous. Okay. This is the start position, so what we care about now is the colors. This shouldn't be colored. Okay, I also, yeah, let's do, no, let's do 4xy and just, I don't know where to write it. 9890, x plus dx, x plus dy. What's the color of nx and y? Two of these must be the same color. The ones that are the same, oh, they're not. Okay, well, I just have a bigger bug that this seems like an issue. Oh, what the heck? If x, y not in CC. Okay, they're all color 36. That's unfortunate. So the pipe could be, what? Okay, and then I am definitely missing leaderboard today. I just have so many bugs. These are like the colors and their frequencies. I'm just trying to like sanity check. Okay, sure, that's like insane. What? Oh, the pipes nearby must just tell us, right? Wait, I'm doing this now. Why did this not work? Oh, that's why. They're all vertical pipes, so it must be above and below. And the question is, wait, this doesn't even matter. The question is like the length of the pipe. Take the longest number of steps along the loop to reach from the starting point, regardless. Yeah, I just care about the size of the loop. Okay, I just care about the size of loop with value 36. And then it's this. There's that many things in there, plus 1, including our current one. So I think it's just this. See, if the loop is length 5, then it's 2 steps away. So I think this is our answer. No. Oh. The distances for each tile on this loop. How big is this loop? Okay, so this should just be... this is silly, but... okay, now I have that. And then what's going on? Nx and y. Oh, it's because the start is on the edge. That's silly. Not a problem with my real input, so I'm not going to think about it. Okay, now we have a problem. And that is... where is this happening? Oh my god, I don't remember my editor. Go to line. The key error is in CC. Okay, it's not necessarily in CC. Okay, so 3, and then again, if I did, it's 15. There's 15 things in this loop, and the answer, I needed a, no, 15 things, and then there's, including the S, there's how many? Including the S, there's 16. Wait. Farthest point from the start is 4 steps away. I'm confused. Oh, wait, no, what? Yeah, in this example it's 4. In this example it's what? Oh, the answer is 8, right? The loop here is length 16 in total, and 16 over 2 is 8. But in my previous example, I think it's still... I'm confused. What did I submit? I submitted this. Let me just try it one more time to make sure. Okay, so I submitted this. Oh man, this is brutal bugs. Not 6912. This was the sum of my loop. Everything on that color. Even if I add 1 divided by 2, it still shouldn't make a difference. The loop is 4 long. Wait, can it be like an odd number? And this one is 2, 4, 2, 4, 7 is the thing that I would get. So it's odd. Again. Wait, is it possible to be odd? Or to have an even number? Or the loop should be... And the loop here is of total length 8. I'm very worried I have a bug in here somewhere. Like a non-trivial one. Oh man. I didn't just like fat finger a number, did I? And then... to just this plus the start. Like clearly the start must just be a vertical pipe, right? In our example. So I think that if you hypothetically had a loop that was 4 long, I mean, am I really just getting silly off by 1 here? Am I thinking really slowly about this? If your loop is total length 4, including the start, then the answer is 2. If your loop is total length 5, including the start, then the answer is still 2. So yeah, it's like divide by 2 in floor. So it should be, I mean, I really think it is this, if my other code is correct, which it's not, of course. Oops. Where is the start? I'm not going to see it by looking. Where did I say it was? 9890? I'm not doing something silly here, am I? And X and Y? No? I don't think so. Okay, so G 98, and let's just look at characters like 80 to 100. Yep, 2 pipes, and there's the start. Can I fit 140 characters? Probably not, but... Okay, and then what we'll do is we'll do... This is supposed to be my loop. Does it look like a loop? Yeah, sure. Oh wait, maybe I could do something else. I could even do, if I wanted to see the loop. I'm just trying to see if I have any like obvious bugs here. If we do this, then it'll be g of x and then of y. And I can... Does this look right? Yeah, I feel like it does. And it must be one single continuous loop. Unless I have bugs in my adjacency code. That would be sad. I feel like the examples might have been able to catch those. I'm just skimming these to make sure I don't have any obvious duplicates. I don't see any. Oh man. Alright, let me just look at the leaderboard so that I know that it's still not full on part 2. Part 1 was, of course, full, like 8 minutes ago. Let me read the problem more carefully. Okay, I'm gonna do something quite ridiculous, which is just actually number the units. Wait, it really is like the right distance metric, right? It's like pipe distance. Yeah, it is pipe distance. And just to be clear, if I have like 0, if I have like an odd length, is it really possible to have an odd length thing? Like, is that indicative of a bug that I have too many things in this connected component? I feel like it might be. I guess the thing we could do is we can sanity check the connections. So for x, let's do the following: x, y, c, and c the items. And we can find the adjacencies. I didn't override adjacents for it. No, I didn't. This is just going to be gr x, y. And what we can do is assert x, y in the adjacencies of the first one and in the second one. Oh, we're not. So clearly our pipes don't always connect up. That is very sad. Oh, is it an off by? Is it like when it's negative? Because I do -1 and then, no, but I should be checking. I do all these range checks. Tell me I didn't mess that up. If I mess that up, that's going to be super sad. Well, anyways, let's just check. So gr of xy, these are the adjacencies. G of x and y is a line piece. This, so this is, so x is 0, it's in the first line. Okay, yeah, this seems fine. But what's on 035? 035 is 7? Wait, this should be fine, right? Wait, no, what? Something's wrong. 036 connects to 035 via a line. Okay. I'm centering on 36, so I gotta do this. This is 36. And clearly this can't be hooked up to the... Oh, a bunch of the pipes are like worthless. And okay. So we only actually want to connect if, oh my god. We only want to connect if the pipe connects back to us. Otherwise, like, we can't do this connected component. We kept like spilling. Like, if we start on the right thing, then we're fine. But if we start on the wrong thing, we could spill into other things. I see my bug now. Okay. For an x and y in, okay. If all of these, and also x, y in gr of an x and y. Get rid of these boys. What is going on here? This is just the whole thing is just a check. Okay, 6903 is a new number now. And it is the correct number. Wow, look at that. At least I got triple digit. That's within the area enclosed by the loop. Okay, how many tiles are contained within the loop? How many tiles are enclosed by the loop? Okay, well, that just doesn't seem that bad. I just do it. Wait, what? 4 tiles outside the loop. Squeezing between I is within the loop, where O is outside. Okay, never mind. It's not as easy as I thought it might be. And that is because you need to worry about like Ugh. Where's the start? It encloses these, and those are not. Oh, because they're connected to the outside. Is that just how easy I think it is? I'm trying to think. What do we want to do here? How do I define being enclosed by the loop? It basically means that you can't reach anywhere outside the loop. So I think we just want to wait, yeah, we just no. Yes. Oh, this is still outside. This is outside because oh man, this is annoying. You gotta keep track of so you follow the loop, and then I guess like as you're going down, you keep track of the fact that to the left is inside, and then to the right is outside. So these are still outside. Is there a simpler way to do this? I think there might be. Oh, there is a simpler way to do this, and that's to like expand the grid. That seems quite annoying. Is tracking like the right-hand rule type thing easier? I don't think so. Like if we just expand the grid so that each one of these becomes like a larger cell, then this is like fine. But then that makes the grid quite large. It's not too large, it's just like 420 by 420. Because we'd replace each of these triple things with like something else. Let's just expand the grid. Let's just do it. So, ooh, whoops, what happened here? Okay, there we go. I really don't think it's easier to do anything else. Yeah. Oh. Okay. There's probably something easier that I'm just not coming up with right now. But what we'll do is we will replace everything with something else. So xy maps to 3 times x, 3 times y. And then what we do is, yeah, okay, so new grid. This is just going to be a set of cells that are on and a set of cells that are off. So we set for xy, cc, or c and cc items, if c is equal to, oh, now it's 47 is our group. If C is our group, then what we're going to do, I'm trying to think. Technically, I want to do this because of when x and y are 0. Technically, I could do something easier. This is so hacky. Okay, let's just do it. I'm adding a buffer of 1 around the side so that I can do something hacky later. You will see how it goes. I think we just add this for starters. So add 2, 2. And then what we need to do is g of x, y is equal to this. Then I think we can just keep using these same adjacencies. Yeah, that's actually quite cool. Okay. I don't know why I made this all caps. What we'll do. So now our grid is just big. And what we'll do is we can start at 0, 0, and we'll go to let's go to n times 3 plus, I don't know, I'll just add more buffer, and then n times 3 plus 4, and we'll just do, again, another flood fill. But this time what we care about is, oh crap. No, this is not too bad. Outside will be a set. This is gonna be a big set. It'll be fine. All right. Just copy my DFS. No, I need to copy it. Actually, don't need to check anymore. I'm wasting time cleaning up my code when... Is it possible to get leaderboard? Looking is even wasting time. It's still possible. Okay. So here's what we're gonna do. Pop this, if it's in range, n times 3 plus 4, and 3 plus 4. Okay, so we found a thing. So first check it's in range. Then this should already be an outside, but for the xdy and adjacency 4, if I suddenly don't like this approach anymore. Okay. Well, anyways. NY. Should not mess that up. That would be very sad. If they're in range and they're not in the new grid, then we expand. And not an outside. Add eagerly. I know this is, I've written like the hackiest DFSs here, the hackiest Q-based DFSs, but please don't flame me too hard. I think this should finish, and just like, look at that number. Whoa, that is a small number. What? What? We should have started at 0, right? Oh. Queued up pop, -1. X, Y. We didn't find anyone? Okay, well I agree with those, but... Really? 0, 1 is like not fine? Oh, wait, yeah, no, we're only adding... in new grid. Oh, not in new grid. Okay, and that's now good. Now the question is, how many grid points are inside? So, for I in range, and if 3 times I plus 2, 3 times j plus 2, not in outside. What? No. Sad. Okay. Come on, this might work. No. Okay. I think 4 too much. No, I think this should just be fine. The problem is, should it be higher? Should I add more buffer on the outside? If this gives a different answer, then the first one's wrong. Okay, it's the same answer. Oh, wait, no. This is still just grid points. Many bits of junk. So the idea is I was sort of padding it a little, hoping that the padding would be good. Let's see what this gives. What? 162? Clearly that is wrong. Where's my N and M? Yeah. Oh, I gotta exclude. No. If they're in the big loop, if CC in CC and CCIJ is equal to RG, continue, skip them. 3, it's still quite wrong. All right, if it's not an outside, an IJ. I don't think this will really help, but these 3 lines, 5, 0, 5, 12. No, the pipe should connect up. I'm trying to think if my hacky thing here worked or not. What I would like to do now. Okay, so here's an example with this has like no garbage, right? Okay, I think leaderboard is probably done, so I'm just going to focus on doing this correctly. This has 8 tiles. Let's start by looking at my expanded NG, my like new grid, and what I would like to look at. Also, let me look at this line. I just realized I haven't looked at this block of code that much. I just want to sanity check, make sure I don't think there's a bug in it. Yeah, I think I'm okay with this. Yeah, so let's just look at NG. And let's do, so our new grid size, by the way, should be 3 times n plus 3, and then plus 4 gives us 1 of buffer. Yeah, okay, I was just rethinking that again. And what we'll do, what did not, this clearly did not work. There's, okay, my pipe explosion method is not that great. Wait, what? Yeah, no, ng.add, what? How is it not? Okay, so here's the first thing. Come on, I'm trying to terminate. Okay, 814, and 814's neighbors were 1118. How is that possible? What? GR? Did my variable name screw me up here? X and Y. Oh, that's the new X and the new Y. But still. Okay. So GR of 0 and 3 were what? Oh, these are the raw neighbors. Oh, I forgot that they're the raw neighbors and not the differentials. Okay. Dx is equal to real x minus x, dy, real y minus y. There we go. Now this will work. And let's get rid of the prints. I think it should give our answer now. Nope, now it says 0. Where's my thing that prints the big grid again? Not that one. This one. Let's see if my grid explosion method worked this time. Okay, it did. So this looks good now. And the question is, why did my flood fill not work? I should have flood filled from here, and it should have found some things inside. And Specifically, there are no grid points in here that are inside, but there should be. Yeah, we're not really finding anything. This example. I'm not DFSing for it. No, I'm only DFSing from 0, 0. If it's, let's see. So I'm intentionally not allowed to cross any of these. And what if we do else? So obviously it thinks everything's outside, so that's not going to show me anything. But what might be interesting is I can keep a counter, if count mod, I don't know, every 100 steps, I can then look at this and I can see how it's filling. 100 steps. This looks fine so far. This looks really jank, but I appreciate it. Where did it sneak its way in? So far, it's fine. Okay, it still needs to fill in these parts. Whoa! I see where it's going to sneak its way in. Oh, it sneaks its way in around the start. The start cell has not been filled in yet. Oh my god. Okay. I just want to get the answer submitted, so for now I'm going to do the hacky thing and just replace the start cell with what it actually is. So I think what I will do is, I know that the start cell in my example is a vertical pipe, so I'm just going to copy the vertical pipe adjacencies, and I am also going to add it to, after I do this step, I'm going to do cc of sxy is equal to our color. And then, okay, I don't want this anymore. No, I don't need this many. I don't need the prints. Okay, 265. Okay, that's correct, 169. That was a really good improvement, but I still did not leaderboard in either part, which is pretty sad. What happened on global? No, Antonio jumped ahead of me. This is so sad. Yeah, and I also fell fairly far down to 16. That was definitely a day where I could have gotten points. I was just very careless. I don't even remember every single bug I had. I had so many. Man, that was unfortunate. Yeah, this visualization on the sample input was kind of cool. Let me actually do like the most possibly correct thing now and get rid of my silly prints. This code is quite the mess. Okay, I kind of want to see this again though, just because it's kind of fun. Maybe I'll do like 300. This on the sample input. So a way we can figure out what the start, what kind of thing the start is. So we'll get rid of this. I don't need this print anymore. Is we can look at the things near the start, and if the start, we don't even need to like figure out the letter, we just need to figure out the adjacencies. So what we can do is we look at these, and then if sxy is in gr of nx and y, if we're an adjacency, okay, so first we just and then, sorry. I think now we just have like the correct things around the start. Whoopsies. I meant to do sxsy there. Where was it? Am I blind? There it is. And then I color it. Yeah, that's fine too. Okay, and yes, now we've patched this little hole, so that's quite nice. It's sad that there's no way to make it like not jitter. I mean, there probably is, but Meh. I think just making this larger should make it not jitter as much, but huh. Oh, it's because all the effort comes from printing, maybe? I don't think this should do anything, but oh, that looks quite nice, except for the fact that we have this. Maybe I can do. Oh, that's so aesthetic. Very, very nice. Yeah, this is what I live for, right here. If we wanted to look even smoother, a cool thing we could do is only print when we actually fill a cell in. We're like wasting a lot of time there. Like our queue had a lot of stuff in it, probably like on the edges that we hadn't checked. Well, no, we did the check here. I don't know what stuff the queue had in it, but it had some stuff in it, surely. Okay, now we get the right answer. That's neat. Also, this can become more generic. So let's only do this whenever we add something to outside, which, whenever we add outside is like here. It could already have been added there, but there we go. Wait, what? Sorry, did I say this? Huh? We're adding 1 and then every 1600 we're printing? There's no way. I did something wrong, right? Oh, it's because it's 0 right now. Wait, what? Hang on. What is going on? Oh, I cannot write code. Oh, sorry. I mean, this is what it was supposed to be, but like, it was skipping every 1600 instead. Okay, so it's just printing every time. I should go a little faster now. Sweet. It's really zipping around. What is it doing during that off time? Whatever. Oh, that's a nice little animation. Neat. But yeah, I'll comment this out just for keeping my code. And then, what are these prints I have here? Oh, these are these. These are necessary. I don't know what the first print is. One of these prints is the answer, probably that one. Oh yeah, that's the line of outside print. Okay, there we go. And my code should be generic, I think. I guess I hard-coded one thing, which is that if we start on the ends, yeah, if we start on the ends, then this will break, but because it indexes into this. Yeah, or even if we start and don't have something adjacent. It's whatever. I kind of want my code to be nice and clean, but I don't actually care that much. Yeah, we could put this one in too, just to see the aesthetic. Oh, didn't copy the bold. That's good. No, where's the start here? It's on the edge. No, now I have to fix it. All right. Well, which line was it? It was on this line. Okay. Wait, this one, was this the same one as before? I think it was the same one. It just has more junk. Oh, maybe it's not the exact same. It looks a little different, but it looks kind of similar. Probably, yeah, I think maybe this little box here was not there before. Okay, well anyways, yeah, so I spent a lot of time goofing around just now. I guess I will go ahead and explain some parts of the problem. Yeah, so basically our input looks like this, and each of these letters or characters represents like a segment of pipe. So like this is a vertical pipe, a dash like horizontal pipe, and then J, F, L, and 7, which are so chosen because they sort of resemble like in a like 90-degree bend pipe in like various 90-degree angles. Those are like bend pipes. And then there's S, which is the start pipe. And basically what it says is there's one big loop of pipe that we care about. Oh, this printed on the wrong line. Sorry. There's one big, I just saw that it bothered me. There's one big loop of pipe, and this is the pipe that we're interested in. There's also a bunch of segments of random junk pipes that just are like lying around. And the first part basically says, or the big pipe that we care about is the one that has S, the start position on it. And what the question asks is, what is the furthest point away from the start in the big pipe? And this is, because this pipe is like one big loop, if the pipe is length 8, like in total, like the entire circle is length 8, then you know that the furthest part is just 4. It's exactly half the length of the pipe, because the pipe doesn't have any shortcuts. If the pipe was like a tree and not like one big loop, then this would be different. But this is a nice simplification we can make. So all we really need to know, this is the first simplification, all we really need to know is the length or the number of segments that are part of the big pipe. One minor complication is that since S is the starting position of the animal, this is a minor complication. Since S is the start position and indicates where the big pipe, what is part of the big pipe, we don't actually get to see what pipe segment is underneath S. This could be like a little bit annoying because it just means we need to look at the neighboring pipes to figure it out. And because there are junk pipes everywhere, you could end up in a situation where you have like this, and it is extremely not obvious, or not extremely not obvious. It's unknowable from just this which segment S is on, whether it's like a vertical pipe or it's a horizontal pipe. You need to look at so the real question is, only one of these two pipes can like connect up to the other one. So if I were to draw this, so like it's possible for these two to loop up, or it's possible for these two to loop up. And again, this loop could be like really big. But they clearly can't both loop up because they need to intersect. So the way that you would need to figure this out is you need to figure out like, it's also possible that these loop up, to be clear. Any combination of looping up here is possible, in which case, I guess in that case, these also can loop up, and the question is ambiguous. I guess we're just promised that it's not going to be like this. That's probably an invalid input for some sense, but anyways. The point is that even if you make some assumptions, you still need to like look at these neighboring pipes and look even deeper than that to figure out which pipe is the big pipe, or the big loop of pipes. Normally, so the first step in a question like this is to parse the input into something useful. So in this case, it's just take all these pipes, and I decided to represent it as a graph with like adjacencies. So each index, each location in the grid, each x comma y. And my indexing here is a little funky. X is the first index, which means it's technically like vertical, and y is the second index, which means that it's technically horizontal. I always just pick something and I stick with it. That's the most important thing. It doesn't need to actually reflect reality. I keep losing my train of thought. I'm parsing this into an adjacency representation. So each location here, this is actually a dictionary now, and each x, y location will map to a list of the adjacent two locations. And so for instance, if we see like in a J, then we're just going to add like the location above and the location to the left. We're going to add both of these as adjacencies. And great, this specifies your graph now. And if we knew what segment start was, if we knew start was, for instance, a vertical pipe, what we could do is we could just do a process where we like start on S, and we just keep following the path until we get back to ourselves. In fact, I wonder if the people who leaderboarded just did this. Well, anyways, this is the thing I would do if I knew what was underneath S. If you don't know what is underneath S, then you could either guess, which is what I think maybe the people on leaderboard did, Like if you just look at the things nearby and take a guess. In my input, looking at the things nearby, you actually could conclude exactly what S was, because the things nearby were this, and there's only one possible S here that works. It's a vertical pipe. Oh man, I should have looked at that. Okay, sorry, I'm blending in like my explanation with sort of my own thoughts about what I could have done better on today. Well, anyways, if you don't know S and you don't want to take a guess at S, a thing you can do instead is you can run a connected components algorithm on the entire graph. So if you have a bunch of nodes, you can just like actually figure out what all the pipe loops in the graph are and label them each with a color. Maybe there's like a bunch of different pipe nodes or pipe loops, and label them each with a color. And then you can look at the colors that are adjacent to the S, and maybe we realize that like this one is orange and the other two are like green and blue, and that way we could conclude that it's a vertical pipe. Yeah, so this is the approach that I went for. The first major bug that I wrote was the fact that if you have random junk pipes lying around, they won't all be part of loops. So, for example, if you had a pipe like this, and S was let's just look at an example like you have a vertical pipe, a vertical pipe, a vertical pipe, and then here you have a horizontal pipe. If you try and flood fill this thing, or connected components this thing, and you ask what are his adjacencies, he will tell you that his adjacencies are this pipe and whatever pipe is here. Clearly it's not this pipe, like these are not connected, because this is a vertical pipe, so this must just be a junk pipe. Or at least, yeah, this must just be a junk pipe. This one could be a junk pipe, but it might not be. And what my algorithm was doing was it was incorrectly, so when you run the connected components algorithm, you basically start on a pipe and then you do a depth first search, or you start on a node, do a depth first search, and along your way, you just mark everything you see under that color. That's what this CC dictionary is. It's like colors of each location. And this is just a straightforward DFS, non-recursive because my recursive one kept breaking because I think I had a different bug, but that was not as major. And all you do is you go through every possible location, you bump your color. When I say color, you could just use an integer to represent it. You bump your color and then you DFS. But yeah, well, like I said, I was accidentally connecting together pipes that did not make sense to connect. And that resulted in a very wrong answer. The fix here is, of course, just to look, whenever you think that these are adjacent, actually check to make sure that the pipes agree. If the left pipe here connects to the right, they both connect up, then sure, these agree. These two pipes are adjacent. But if the left pipe does not agree, as in this case, then you should just not consider this an adjacency. So you should break that adjacency. If that makes sense. In some sense, this is like turning a directed graph, where this is like directed edges going left and right, and this is directed edges going down and up. In some sense, it's sort of saying only keep edges that are bidirectional, and there's no bidirectional edge here, so you break this edge. Anyways, that's what I did to fix it, and once I did that and ironed out any other bugs I might have had, I think I might have had some other small ones, then this just works, and we have a number and we have an integer for every pipe loop or pipe segment, I guess. And I just looked at the pipes near my start location and they all have the same color. And I think I also just looked at the pipes again and then they look like this. And that just tells you that start needs to be a vertical pipe. And I guess in this case, you don't actually. So I think the way to do this truly programmatically is, oh yeah, I did this in kind of a funky way. Is you look at the colors of these four things, and one of them must be repeated twice. It could be repeated more than twice, but you look for the one that's repeated twice, and the one that's repeated twice has to be the color of the big loop, and so that's the one that S is part of. So then you look at the size of the big loop, which you can just count. That's what I do here. Size of the big loop, add 1 for the start, divide by 2, and there's your answer for the distance from the start. Cool, so that's part 1. And then part 2 now says, figure out how many cells are inside of the pipe. And by inside, it means like sort of boxed in. But it's a little weird because in this example, zoom in a bit, these are like obviously not boxed in because you can like just walk straight to the outside. And these obviously are boxed in. But actually the definition of boxed in that they want is a little different, because in this example, you look at these and they sort of seem like they're boxed in because you can't walk to the outside. But really, if you think about drawing this loop, and you like connect everything up, I'm actually just going to do it. Whoops. No, I lost my undo. Oh, these are, oh, sorry. Whoops. I saw the eyes. I thought they were pipes. They are not. If you actually connect it up, and then you sort of look at what's inside, and you flood fill it, you notice that these cells are not here, right? Like there's just an inside and an outside. And this is true because there's like this little path here, which is not even a full cell wide, but it is still a path here. And this is like pretty, I couldn't think of any great ways to do this programmatically, but one thing you can do is, if the whole point is that like there's secretly a path here, you can actually just replace each cell with a bigger cell. So you can do a map such that a single cell of a 7, remember 7 connects like left and down, single cell of 7 will instead map to a 3x3 grid where the center is full, this is full, and this is full. And if you do it this way, then like now you can sort of see that if we do this whole process, this part down here will look like, debating how fast I draw this. Oh, my painting skills are very subpar. I'm just trying to do this fast. We'll have like, oh, I didn't draw enough. This is sad. Okay. I can connect this and then I can just fill them in. Sweet. Yeah, so like if we look at this J will look like this. Then we'll have a vertical piece, and then I still did not draw enough. Fortunately though, I think this is the last one I need to draw. Cool. Then there's a vertical piece. By the way, this J that connected to another thing. So then there's a 7. The 7 looks like this. And then there's some other stuff going this way. And I guess I can fill in partially, but and then this sort of continues off this way. And the other side will look like this. Oops. And now we can sort of see that like if this were outside, if this cell like here were outside, then it like does flood fill, or it does fill all the way through up into the center. So that's what I did. I just explicitly did this mapping from cells to 3x3 cells. I say explicitly. I did it like a little, like not completely explicitly, but I just created this new grid. And this new grid, remember now it's just like a cell is either filled in or not filled in. So I can just do it like this. And I reused the adjacencies I already had computed in a clever way. So now I have my big grid, and you can see I had some lovely visualizations of that. Yeah, like this. Very neat looking. Cool. And you can see that like any given 3x3 here, where the middle is like full, this is like one cell in the old thing. And you can see that previously, right, like where there was no gap, like I think this was a J and this was a L, and there's no like gap. It's like JL immediately. But now we've sort of introduced like a too wide pathway. And once you have this, you can do the straightforward-ish thing of just like flood fill from the outside, and then you know where all the outside cells are and where all the inside cells are. And I have like a little nice text animation of this. And that flood fill is again done with a depth first search. Yeah, I'm trying to think what else was notable here. Oh, sure. Once you have this, you can't just actually look at the number of non-filled cells, because remember, we've blown up the graph, right? Like it's much bigger now. So what was like one filled in cell here is now going to be is now 0, because this was a 7 and it was like not a full thing. Whereas these were inside, and like technically the 3x3 cells look like, oh, I drew this too close. Oops. I can fix that diagram, but there we go. I fixed it. The 3x3 cells here look like this. Cool. And you'll notice that like this 3x3 cell, which was empty, now counts. So basically the way to do it is just, we still have the old grid. So go through points on the old grid, which is this old like 0 through n-1, 0 through n-1, convert the points into the new grid, like figure out their coordinates, or the coordinates of their centers, and then look at the centers. And if the center is empty, then it is good. If the center is full, then it does not count. So we're just counting the number of things with empty centers, and that lets us like avoid having to do some weird conversion factor from the. I don't think you could do that, to be honest. But yeah, and that's the way that you figure out how many cells are inside. Cool. And yeah, that was my approach to part 2. Yeah, I don't know. I'm trying to think. I'm still curious if there are any other neat approaches for that. I think obviously my code is pretty horrible. I think all things considered, this ended up being a reasonably elegant approach. It's also very visual, which helped for debugging. The fact that I could just like multiply the coordinates by 3 and then add some offset was quite nice. And also the fact that I could, like, I was worried I was going to have to write these mappings explicitly. Like I was going to have to write out the fact that this maps to this, write out the fact that J maps to this. Oops. And this would be like kind of a pain if I had to write this and take up a ton of time. But the fact is that since I already had these, you can actually just reconstruct these from the fact that like, you know that J has an adjacency going up and going to the left. So you can just take the center point and then go up and to the left. But yeah, anyways, that is all I have for day 10 of Advent of Code. Yeah. I think if I had fewer bugs, my approaches were good enough to get on the leaderboard had I not written bugs. I think there are things I could have done faster. Like, had I looked at the input, I would have immediately known that start was a vertical pipe, and that would have saved me a ton of time because I wouldn't have even had to write the DFS. I could have just written some like simple follow the path algorithm. Or I mean, maybe I could have even still written a DFS, but I wouldn't have had to write a connected components, which honestly is not that bad compared to the DFS, but I don't know. Yeah, one of my big bugs here that resulted in the infinite loop was in connected components, I often like to use the connected components set, the colors set, which maps like node to color, as the scene set. So in a DFS, you need a scene set so that you don't like go back over yourself. I like to reuse it for that, and I forgot that I was using it for that, so I didn't have this condition, I believe, and that just causes you an infinite loop, which is pretty sad. So, but yeah, I think I keep rambling a little. Definitely things I could have done better. The approaches I had were definitely not the fastest things to write or perhaps run, but yeah, it was a tough day. Yeah, that is all I have for day 10. See you tomorrow.